Okay, Leetcode challenge number 34. Finding first and last positions of a target in number list that was passing parameter. So we're going to find the target in our nums list. Now we're going to use binary search and we will divide and conquer our list. Okay, so we're going to need first equal to first search. It will be, we're going to pass nums and target. So we're going to have to copy this and use it for the last next positions. So it will be last search. So these first and last will be the index positions of the target in the nums list, and we will return that first and last index positions. Okay, we're going to need to write the first search functions, and it will take nums and it will be list, right? List of integer, and the target will be integer, and we will return the index positions. So now we're going to use binary search. Before that, we have to make sure if we couldn't find the target in our nums list, then we will return -1 as requested. Okay, so left will be equal to 0, and then we're going to need nums length for our length, and it will be the right length. So nums length equal to that. So now the while loop will be left is less than right. Yeah, they can be equal to, I guess. They meet in the middle, right? And then if we will compare the mid with the target, so nums mid. Oh, we forgot to calculate our mid. Mid will be left plus right minus left, and if half of that will be the mid positions. So now it's the same as the target. If it's the same, then we will return our mid positions. So now we still need to write the more logic in right here. Right before that, we will have to make sure the binary search is working correctly. And the logic of the binary search is basically we are comparing against with the target again. If the mid is greater than the target, then we have to update our right index positions. And we are moving forward to the lesser number for uh, us to find the right target. So now if it's not that the case, if the mid is less than the target, then we have to update our left positions, which is mid plus 1. Okay, so now we're gonna write the logic inside here. So the logic is basically, is it the first number is the mid, the target, or if right before the number the mid, right? So it will be mid minus 1 is not the target. So if the current mid is the target, that's what we making sure we are making sure that. So if it's right before current mid, is it the target, right? Is it the first target in our list? And we will, if the mid is greater than or equal to 0, that means are we within the boundary. If all these are true, it will return the mid. Okay, so if it's not true, then we will have to update our right. It's mid minus 1, meaning we have to move lesser to the lesser number in our list. Okay, so now the last search. So everything else the same, but we're gonna have to change negative minus into plus, and then we will change this into nums lane, and then the last one will be nums lane and less than or equal to the mid. So is it within the boundary? Is it the last target? is the mid is the last target. And now we're going to have to change the left. If all these are not true, then it should be moving forward to the larger number. We're moving forward to the larger number. So we're doing right. So let's make this bigger. So that's our answer. And let's try and demonstrate this in our code. So first, it's going to be what is it called? Search range. Okay, so we are passing the number from given list. So it should be 3, 5. So 5, 7, 7, 8, 8, and it will be 10, and the target is 8. So should be returning 3 and 4. Yeah, that's correct. So the solutions big O of the time complexity will be big O of log n because binary search, right?